Dead Men Tales is brought to you by SupplyHouse.com. Heating season doesn't have to be hectic season. You can get repair and maintenance parts from industry-leading brands delivered quickly to you with SupplyHouse.com. SupplyHouse.com has a large, well-stocked inventory of over 300,000 parts and offers free shipping on orders over $99. Trade pros can join the TradeMaster program for free shipping, a dedicated customer service phone line, lower prices, and more. Shop now or learn more at supplyhouse.com/trademaster. That's supplyhouse.com/trademaster. Make this heating season easy with supplyhouse.com. From heatinghelp.com, it's Dead Men Tales. I'm Dan Holohan. In the beginning, there was one-pipe steam. And one-pipe steam was pretty simple. The steam traveled up the pipe, the condensate fell down the pipe. Size and pitch the pipes properly, don't overfire the boiler, keep the wet returns clean, and you were in pretty good shape. As buildings got bigger, one-pipe steam became somewhat impractical because there was just too much condensate draining down against the uprushing steam. The dead men got around this for a while with the mill system, which sent the steam up to the attics through an express riser. From there, steam flowed downward toward the radiators, taking the condensate with it. That's called parallel flow, which is a lot friendlier than counterflow. When the rich folks decided to have steam heat installed in their homes, they complained about the one-pipe steam air vents on the radiators because the vents would often spit dirty water on their curtains and wallpaper. The dead men gave their concerns a lot of consideration and invented what we today call vapor heating. Vapor means you're working with very low pressure, usually only about 8 ounces or so, and that you're going to have a 2-pipe steam system. They sent the steam up to the top of the radiator with one pipe and drained the condensate from the bottom of the radiator with a second pipe. The steam pushed the air through the radiator and shoved it out of the system through a big main vent, which was typically at the end of the dry return right near the boiler. If that vent spit dirty water, the water went on the basement floor and not on the curtains and wallpaper. No big deal. The rich folks were happy, and the art of steam heating progressed. But when you have 2-pipe steam radiators, you do have a challenge. These systems are set up like ladders. Each radiator is like the rung on the ladder. One of the ladder's uprights is a supply line, the other is a return line. The dead men needed a way to stop the steam from scooting from one side of the ladder to the other. This was important because for steam to move, they needed a point of high pressure and a point of low pressure. If the steam could find a shortcut through any of the radiators, it would pressurize the return side of the ladder and the air wouldn't be able to get out of the other radiators. The result would be no heat. So the dead men came up with all sorts of neat devices that would stop the steam from getting through the radiators. They used orifices and little check valves and tiny steel balls and water seals and whatnot. And then they came up with the idea of the thermostatic radiator trap, and that idea stuck around for a long time. A thermostatic radiator trap is an automatic valve that responds to temperature. It's normally open. It lets the air by. It closes when the steam arrives. It opens when the steam condenses back to the liquid we call condensate. It sets up the points of pressure and no pressure throughout the system. But radiator traps fail after a number of years, and they usually do so in the open position, which is when the problem begins. Without a difference in pressure, nothing moves. Steam traps trap steam, so there's little or no pressure on their outlet side. That gave the dead men another challenge because with their one-pipe systems, they had been using the leftover steam pressure at the end of the main to help put the water back into the boiler. If they sized their pipes properly, all they had to do was allow for a vertical distance of 28 inches between the boiler water line and the bottom of the lowest steam pipe. They called this the A dimension. The water would stack in that vertical space, and its weight would combine with the leftover steam pressure at the end of the main. Those two forces were enough to overcome the pressure inside the boiler and get the condensate back where it belonged, which was inside the boiler. Steam traps changed all that. With no pressure on the returns, the dead men had only the weight of the returning condensate to help them get the water back into the boiler. A column of water that's 28 inches high exerts a force of 1 psi at its base. So on those two pipe vapor systems, they'd need at least 30 inches of vertical space between the boiler water line and the lowest return line for every pound of pressure inside the boiler. The extra 2 inches is for pipe friction. If the boiler ran at 2 psi, they needed 60 inches of vertical height. I call this the B dimension. If the boiler ran at 5 psi, they'd need 150 inches. The trouble was, those old basements weren't deep enough, and that's why they sized the piping for the lowest possible pressure drop. They also invented a device called a boiler return trap, which helped if the boiler pressure went too high. The return trap contains a float-operated double-seated valve. It works with 2 check valves in the return. If the returning condensate didn't have enough pressure to get into the boiler, the condensate would flow into the boiler return trap instead. When it got high enough inside the boiler return trap, the float in the return trap would rise and open a steam line. The steam would shoot into the return trap, combine with the weight of the condensate, shut the outboard check valve in the return, open the inboard check valve, and put the condensate back into the boiler. It was a very simple mechanical device designed to last a very long time. If you see one, the best thing you could do is leave it alone, if it's working. But you may not know that it's not working until it's too late. Here's why. Let's say you get called to look at an old vapor system because the fuel bills are very high and there's water hammer everywhere and most of the radiators never get hot. You suspect, and rightly so, that the thermostatic steam traps on the radiators aren't functioning. No one has ever worked on them. You tell the owners that you're going to have to repair all those traps. You give a price and they give you the go-ahead to start the work. That is, after they stop gagging. But once you get all the traps fixed, the system still doesn't work. Condensate won't return to the boiler takes on fresh water through an automatic water feeder, the boiler floods during its off cycles, there's still no heat in most of the building, the customer won't pay you, you think the traps you installed are bad. You know what's probably going on here? The boiler return trap isn't working. It hasn't worked for years. It seemed like it was working before, but that's only because the steam traps on the radiators were bad. They were allowing steam pressure into the returns. That pressure was causing all those problems they were having, sure, but it was also allowing the condensate to return to the boiler. But once you fixed the thermostatic steam traps, there was no longer any pressure in the return to push the water back into the boiler. If the boiler return trap was working, it could have helped. But it's not working. And you didn't know that because the broken steam traps were covering up the problem. So now without the boiler return trap, the condensate backs into the return and blocks the one main air vent for the entire system. Air can't get out of the system, so the radiators stay cold. Without the boiler return trap, the condensate stays in the return lines. It won't go back to the boiler, so the boiler goes off on low water. Then the automatic water feeder does what it's supposed to do, and when the system shuts down, the returning condensate floods the boiler. You're getting blamed for all of this. You think it's the traps you installed. It's not. So the next time you run into a vapor heating system, look at the whole system and not just the steam traps. You could fix a boiler return trap. You can also replace it with a boiler feed pump. Approach the system as a system and tell your customer what you're doing and what you suspect might be wrong. Tell him you'll fix the traps, but you might also have to fix or replace the boiler return trap. It's easier to explain these things before you start the job than it is afterwards. And these days, you can get instant answers to any steam problem by just asking on the wall at heatinghelp.com. I hope you learned something from that dead man tale, and if you did, please share it. I appreciate you taking the time to listen. Thanks.